So number 11, we want to make it look like one of these, and the first thing we noticed is that the y is squared, so we know it's going to end up looking like this one. Right? There's no x squared, there's only a y squared. So to start it looking like this, let's get all our y stuff on one side and everything else on the other side. So I'm going to subtract 4x, subtract 16, get those out of the way. And perhaps by even the way I set this problem up, there's maybe a built-in hint as to what we're about to do. Complete the square. Because we would like our left-hand side to be a completed square, to be a perfect square. So what's the three-letter acronym for completing the square?
Half squared.
Half it squared added.
We subtract 4 from the other side.
So let's see. Half it we get -2, half of b. Square it we get 4. So we'll add 4. Half square add.
Subtract 4 on the... No, you would add 4 on the other side of this. Oh, that's right.
Right, you got to keep things equal. So you either subtract 4 on the same side, but that doesn't really do us any good, or you add 4 on the other side, which is what we want to do on this problem. So on the right-hand side, I've got -4x minus 12. On the left-hand side, I've completed the square. That's what the plus 4 did. It completed the square and turns this into the perfect square of y minus 2 squared.
You can take out the -4.
On the right-hand side, you have to take out whatever's on the x. So it's not so much a greatest common factor thing. It's whatever the factor or whatever the coefficient of x is has to come out front. So we take out a -4, and so that leaves x minus, that leaves x plus 3. And there's our answer. So yes, p would be -1, but that doesn't really matter for this problem, because we don't need to do anything more with it.
And it's basically the same thing for 12.
It's kind of the same thing for 12. Except x is squared. So speaking of that, why don't you go ahead and try number 12 right now while it's... Okay, so there's number 12. Half it squared, add it to both sides. That completes the square on the left. And on the right, whatever's on front of the y has to be factored out to make it look like a parabola. A little side note here. Number 12, which way is that thing opening or pointing? Up, because the x is squared and it's positive. Back to number 11, which way is that thing pointing? Left, because the y is squared and it's negative, so we know this one would be a leftward parabola. This one would be an upward parabola. Didn't really ask that on those questions, but that's because we test things, we want to test them sort of one at a time rather than make one problem that tests 14 things. Okay, good. I'm glad you asked those, because we have not done a complete the square problem in a while. So what else from that worksheet? I guess first of all, which way is this thing opening?
Left or right?
Well, both of those are right. Left or right, because y is squared, but it's negative, so I know it's opening to the left. So I probably want to at least think about that before I even start the problem, if not draw a little picture to make sure that once I get through all the details, I end up with a leftward facing parabola. So vertex would be 5, -6. So there's 5, -6. What's p equal to in this one? Well, be careful. 4p is -2. So p is -1/2. Alright, so the number in front of the x is 4p. So when we divide by 4, we get back to -1/2. Okay, so that means we're opening left. We knew that already. So the focus will be on the left. Right there. So that's 4.5. You can write that as a fraction or as a decimal. I'm going to go decimal, so 4.5, comma -6. And the directrix would be half on the other side. Is that an x equals line or a y equals line? X equals. And we went half further than 5, so 5.5. And then the last thing we're looking for is the focal width, which would be 2. So a width of 2 or a 2p on either side. 2p is 1. So 1 on each side, or 2 all the way, however you want to think of it. And then, again, it's only 3 points, so it's hard to tell exactly how wide or narrow that parabola gets. I won't be grading for that as long as your parabola looks reasonable and you've got those 3 key points on there. Again, it might be narrower than that, it might be wider than that. It's kind of hard to tell with only 3 points, especially 3 points so close together. Probably should read the directions, make sure we did everything it asked for. Vertex, focus, directrix, and graph. Vertex, focus, directrix, and graph. This one didn't ask for it, but sometimes we ask for domain and range. So let's see, domain is the left-right stuff. Negative infinity up to 5. What about the range? Yeah, all real numbers. So it goes forever up, forever down. Negative infinity to infinity. Alright, so we did a graph, we did a complete square. Do we need to do some of these like puzzle problems on the back here?
Those are like the easiest ones.
The easiest ones. I guess, just be careful. Especially when we start doing silly stuff like 15/16ths. Do we need to 31/4? Do we need to do one of those? Despite Ryan's objections that they're the easiest ones. You got a preference of which one you'd like to see?
Are there things you can test like really weird fractions?
Yes.
It's just 1 less than 8.
But they're weird fractions in the same way that these are weird fractions. Like you start looking at it and you're like, it's not really as bad as it looks, right? Because 31/4 is pretty close to 8. So yes, that looks terrible, but it turns out that means p is just 1/4, or maybe negative 1/4, depending. I'd have to draw it out and think about it. So let's do one of the ones with the weird fractions. Let's just do 15 here. Vertex, -3, -8. Maybe you can do these without graphing, but I feel like I at least need to think about the graph. A rough sketch, perhaps. Yeah, just to figure out which way it's going. So -3, -8. There's my vertex. My focus is -3, negative almost 8. Right? How's that for math?
It's like 7 times 5.
Yeah, so negative really close down in there. But yes, that means we are opening up. So who's getting squared here? The x will be squared. And we have the point, we have the vertex. So x plus 3 squared equals, leave a little space here, y plus 8.
Would you even make the space if it's 1?
Well, let's see here. P is equal to 1/4. So 4p is 1. So you're right, you don't have to put anything in there.
Oh.
I mean, you can put a 1 in there if you kind of want to emphasize that.
I didn't do the 4.
Did you put 1/4 in there? I thought these were the easiest ones.
You should do number 3.
Do we want to do another one of these while we're here?
We should graph
Want to do another square root graph? Number 3 is upside down. How do you know number 3 is upside down? What else has been changed about number 3? It is upside down. Up 3. And maybe that's weird or misleading because it feels like that 3 is in not the usual spot we'd like it. But we could put the plus 3 at the end and that wouldn't change anything. So yeah, up 3. And then lastly, what's that minus 2 do?
Moves to the right 2.
Right 2. So right 2, up 3. There's our starting point. Let's see, it's a square root, so it normally looks like that, except that it's flipped. Usually we go 1, 1, 4, 2, 9, 3, because we're taking square roots. Oh, I left off one of the, maybe I would have still caught it, but what's the other translation from the parent function? Stretch by 4, and of course that goes to the y coordinate, so that will stretch it out by a factor of 4. So this is going to be off the graph pretty quickly here. Let's see, up 3. Oh, but it's flipped over, so maybe we'll see some of it anyway.
Are you supposed to be one negative though?
Yes. Well, the question was, does this need to be negative 4? Some people will put the negatives there. Other people will know that, hey, as long as I flip it, I'll take care of the going down. So either way, it doesn't have to be negative here, but it's certainly not wrong, and it might be helpful to put those negatives on there to help you remember to make sure you flip it over. So over 1, down 4. Over 4, down 8. 1, 2, 3, 4. 1, 2, 3, 4. 5, 6, 7, 8. Over 9, down 12. That's further than I want to go. I guess I could. 9 over from 2 would be 11. Negative 12. I don't know. That's pretty far off the graph to be worried about. So something like that. Looks weird, but we go back and we compare to what we said would happen. We flipped it, we stretched it by 4, we went up 3 and right 2. The domain and range for a greater than or less than one. Let's do one of those. I've done one of those. Any preference on 5 or 6? Reese, you asked the question. You got a preference? Number 6. Is that a bit repetitive to say graph there when it's already within the graph section? Fair enough.
We didn't do the domain and range for the last one.
Nope, you're right. We didn't. So let's see. Back to number 3 for a second. Domain, that's the x's. I'm looking left to right. It starts at 2, goes to infinity. Square root, definitely one side goes off to infinity, so it should include a positive or negative infinity.
If you look, all the x's.
Range would start at negative and start at. That's a weird way to say that, but heads to negative infinity, but we got to put the smallest number first. It goes up to 3. Okay. Number 6, because Reese's question is a good one. Domain and range when you're shading a whole bunch of stuff. We'll get there in a minute. Right 3, up 1. No stretches, no flips. So there's my starting point. So I don't have to worry about changing any of my standard points there. Over 1, up 1. Over 4, up 2. 9, 3, that's way off the graph here.
Oh, there's 6.
Something like that. And where am I shading?
Well, it'd be dashed because it's a.
Good call. It should be dashed. which is unfortunate when I use pen. Do what some of you guys do. You make the mistake and then you're like, it's dashed, I promise. Which, if I'm using a pencil like I ought to, I could go back and erase half the line and make it dashed. So yes, good catch. It is dashed. Now where am I shading? Below. But below only the line that's there, so I can't shade anything over here left of 3 because there's no below what? There's no graph to shade below. So there's my shading. Alright, domain and range is kind of weird. Well, I guess domain's not too bad. Because as I look left to right, my shading starts at 3 and goes to infinity. Would we not include 3? That's a good point. If I put in 3, yeah, it's less than or equal to, but we would not. It's not equal to. So does 3 work, or does 3 1? 1 is not less than 1, so it would need to be an open circle there. That's a, would not include 3. Good call. That's kind of tricky. And the range? All real numbers, because we're looking at the shading, not just the graph now. So even though there's a hole there, and even though it's dotted, like eventually it covers everything.
Everything besides 3.
Well, all the y values are covered, I should say. All the y values are covered.
Oh, yeah.
Did everything flip to the side?
No. It's not. She said we're going to flip left and right. Flipping left and right would require the inside to be negative, and we don't do that for whatever reason. It makes it harder, but we sort of miss out on something. But yeah, if you make the inside negative, it flips it left and right. We don't do it though. Okay, so we've done some of everything from worksheet 1. Worksheet 2 is today's assignment, but since the test is tomorrow, we wouldn't have time to answer questions from it. Ooh, a lot of factoring and a lot of exponents. We did a whole bunch of factoring yesterday. So as you look through, I don't know if you've tried any, but you could just look through. Is there anything on there that you look at and you immediately think, wait a minute, I don't know what's going on there? Those first 4 all have 4 terms, so how are they going to be factored? So those would all be grouping.
Or you could take.
Well,
Let's say you can take out a grade.
there's probably a GCF on some of them, that's true.
Number 1.
2 has a GCF.
Number 1's at least 2A.
1 is at least 2A, yep. So GCF first and then grouping.
Number 11, I did the cubes.
Number 11. Great minds thinking alike. Cubes. But what do we look for first? Greatest common factor. Take out a 3. It wasn't really a sum of cubes until we took out 3, and now both of those things are perfect cubes. So what would we cube to get to 8x cubed? 2x. And what would we cube to get to 1? 1. And then, yeah, now I'm thinking about soap. So same, opposite, always positive.
This is the stuff I don't do.
This is the pattern you got. This is a new type of factoring. Yes, and you've got to memorize this pattern.
You square the first one.
Square the first term. Cooper, what do you get when you square 2x?
4x squared.
Good. Make sure you square all of the first term.
And then you multiply the 2 terms together.
Multiply the 2 terms together.
So you just get 2x.
It's just 2x.
And then you square the last term, which is just 1. Beautiful. And
Beautiful.
I don't think that can factor anymore.
That's right. The second term looks like it. You should think about factoring, but it won't ever factor. That second set of numbers, you don't have to think about trying to factor because it won't. The only caution would be if you didn't take a GCF out first, you might be able to take it out there. But if you took the GCF out first, like you're supposed to, then that second term won't factor. So that was a good one to do. It had a cube in there, and it also had a GCF in there, so a two-step factoring. In fact, it looks like most of those are more than one-step factoring. In fact, I'd say they're all more than one-step factoring. No, 14, that's nothing you can do with no GCF on 14.
That's just the square. Or the.
Yeah, 14 should be pretty similar to number 11. Yes. What would you cube to get to 64x cubed? And what would you cube to get to 125? 5. And so then you're off and running. These big numbers. I don't want to gloss over the factoring, but we did a lot of it yesterday. Do we need to do some of the exponent stuff, the last 8 problems or so? Which one?
Not number 30.
Not number 30. That's a good call to not do number 30. 23. Let's see. What do I want to do first? So, you want to clean up the inside, or you want to do the 4 first?
I think the 4 first.
I think the 4 negative.
It doesn't matter. You guys want to do the 4 first?
Then you don't have to worry.
I want to do the 4 last.
It doesn't matter.
You can cross out the 1.
Again, it doesn't matter. You got to handle everything eventually. I would probably handle the 4 last because I'm looking like I can simplify some stuff in there.
It's like putting the greatest contractor back in.
So I think I'm going to handle the 4 last. I'm on Jackson's team on this one. Because I see some things that can simplify pretty quickly here. Like the 2's go away. How many x's do I end up with?
5.
Trying to not skip too many steps at once here.
It's 5.
Wait, don't you get 5?
Where'd 5 come from? I like that. Where'd it come from?
You move over the 4, you have 8. Let's subtract 3.
Put that in the top. That's 8 x's in the top. Canceled with 3 in the bottom.
Oh.
So that leaves me with 5 in the top.
You just take them off and flip over Y2.
And then flip over the y2, and the y0 doesn't do anything. It's like, why is that even there? So y squared in the top.
You have 1.
And we really don't have anything in the bottom. I guess I can put a 1 down there so it doesn't look funny.
You could just get rid of the bottom.
I could get rid of the bottom. I don't need the 1 in the bottom. So x to the 20th, y to the 8th. So let's do 25, and let's do the exponent first on that one, just to take it a different way. Plus, I see some negative exponents, so when I multiply by -1, it'll,
Cancel out, right?
I guess it'll fix the ones that are negative, but mess up the ones that are positive. So u squared, v -3, u squared, over 2 to the -1, u to the -4, v to the -4. Because I just put that -1 on everybody. so it fixed a couple of them and messed up a bunch of them. All right, what about that 2? Where's the 2 going to go? 2 will go on the top.
Sure, nothing at the bottom.
And then, I should be careful here, but how many U's am I going to end up with? I think you mixed up your V's and U's, yeah. I think I got 2 in the top plus 2 more in the top make 4. That U to the negative 4 goes to the top.
Yeah, I best.
So there's 8 U's in the top.
How do they use U in?
Yeah, that's kind of stupid.
And then V, they're both negative, so let's be super careful here. In fact, I'm worried about messing this up, so I'm going to put an extra step in there. Flip them both. Yeah, it ends up with just one V in the top. 2U8V. And again, maybe I should have done the inside first and cleaned it up and then flipped everything over, but it doesn't matter. It should land at the same spot.
This is tomorrow. First period.
Test is tomorrow, first period. That's right. It's a block day, so you should have plenty of time.
I can't ask anybody what's on the test. Everyone's asking me. It's true.
And are you telling them what's on the test, or you
Absolutely not.
only hurt yourself, right?
Honestly, I say I don't.
You're in a class rank competition, so
And most of the time I don't remember.
Yeah, that's what I'm saying. I don't have.
that's what you should tell them. Or don't lie, just tell them it's easy or hard, but don't give them any
There's numbers on
details. There's numbers on it. There's factoring on it.
You gotta put your name at the top of the paper. You should put the name blank at the bottom of the test. Like just.
Some of you have a hard enough time putting your name at the top when it says name at the top. Like let's master that first before we
Make it like a question. Make it like question number 8 or something.
Yeah, just
write your
Right on
name.
the second page, it's like question 8, your name.
Maybe that would encourage some to write their name.
Should be like a 7-point question or something.
What if I just, it's not a terrible idea, what if I just renumbered it and put number 1, name, and then start numbering from there, 2, 3, and so on. Maybe that would help. Usually it's not the test though, it's the homework that people have trouble putting their name on.
Looking around for number 1.
You see that it's your name.
I wouldn't find it.
You'd be looking around for number 1, yes.
I would too.
Why is this starting with number 2? What is
I would
Mr.
write
Wolf
my
doing?
name, not even